In this lecture, we're going to take a look at the topic referred to as being fins. Now, fins are found in many, many different types of engineering applications. Quite often, we will see them in things like lawnmower engines. Electric transformers have fins in them. Quite often, if you look at any electronics, there are cooling fins, and air conditioning systems have fins. But primarily, what we are interested in, our primary interest is how much heat they are removing from a surface. And so that is a bit of a simplification of what the fin does, but that's typically what we're after when we're doing our engineering calculations. And there are all kinds of different fins. If you look at them from cross sections, you can have straight fins that do things like this. You can have fins that do tapering. You can have fins that are wrapped around a tube, as we're going to see shortly in a video clip. But the fins that wrap around a tube might look something like this. I apologize for my artwork not being perfect. And these fins are quite a bit different from planar fins, because here the area of them changes as you go further and further away from the fin. But typically what we're going to do, we're going to assign a coordinate system, x being in the direction away from the surface that we are trying to cool. And so let's say this is, we refer to it as having temperature of the base. And you could be heating it as well, depending upon the particular application that you're looking at. But then what is happening is we have a thermal energy coming out through conduction. So energy is conducting through the fin, and so that could be Qx. And at the same time, the amount of Qx going further and further out along the length of the fin is getting less and less, because we're losing energy to convective heat transfers. So we have some fluid media here. And so consequently, Qx is going to go lower and lower as we go further and further towards the tip. And we refer to this as being the fin tip. So that is kind of a very, very simple view of how a fin is performing. And what we'll be doing in the next segment is we will come up with an equation that enables us to model what is going on within a fin. But as a result of this, what a fin is referred to as being is a convective system. And the reason for that is we have conduction and we also have convection. So here you'd have T infinity H, and that would give you the convective environment. So what we're going to do now, let's take a look at a video clip of some common fin applications that you might find in everyday life. And then what we'll be doing in the next segment is we're going to go into the theory, and we're going to come up with what is called the fin equation, which enables us to move towards estimating the amount of heat removed from a surface due to a fin. So let's move on to the video clip, and I'll talk through different types of fin applications. And the first one that we're going to begin with is, this is a refrigerator with a thermoelectric cooler in it. And so if you open the door, you'll see in the back there's a grill, and that's where the thermoelectric cooler is. When you remove the panel, you'll see there's the aluminum base on the left-hand side. That has fins on it. And if you flip the fridge around and you take the back off, you'll see there's an electric circuit board at the top, and then there's a thing with a fan at the bottom. And if you go in closer, you'll start to see there are fins, and the fan is providing forced convection to cool those. When you look from the side, that gives you the profile of the fin. And so that's another example of a pin. This is inside of a Dell computer, cooling fins all over. This is an air-cooled engine in a weed eater, and there you can see the fins. This is a lawnmower engine, cooling the head. And this is a compressor, and compressed air gets hot, and so we want to remove the heat there. This is a classroom in Reykjavik, Iceland, and there you can see a radiator on the bottom, and that has fins which enable us to transmit heat into the room. And then up higher there was another radiator, and there are fins there, and then this is another hot water radiator. You can see the fins wrapped around the copper tube. Looking at the IR signature, you can see that the fins are getting hot as hot fluid is circulating through that radiator tube. So those are some example applications of fins. What we're going to do in the next segment, we're going to move into the theory, and we're going to come up with an equation that enables us to start to quantify the amount of heat removed